So, we talked about the second postulate of a special theory of relativity, that is the speed of light is same in all inertial frames irrespective of the relative motions of the frames, and how it comes from the experimental observations. The other postulate, first postulate, is that laws of physics or laws of nature have same form in all inertial frames. So, that is principle of relativity. The motion of one frame with respect to other frame is only relative. There is nothing like absolute rest, nothing like absolute motion. So, it is all relative, and therefore, if you have two frames and one frame is moving with respect to the other frame, both frames are of the same status. Any of them you can call it at rest, the other is moving, and hence the laws of physics must be same in this frame as well as in that frame. And that means any experiment you do in one frame and you get some result, that is governed by the laws of physics. If you repeat the same experiment under identical conditions, but in that other frame, still you will have the same result, because the laws of physics are same, and hence the result of the experiments will also be same. So, by doing any experiment in a particular frame, you cannot say that this frame is moving or this frame is at rest. So, that is principle of relativity. Laws of physics have same form in all inertial frames. For example, you make a pendulum, oscillate it, find the time period, and you find the time period is, let us say, 2 seconds. Now, if you do the same experiment, take the same pendulum in some other frame, in some other car, in some other trolley, which moves with uniform velocity in a straight line with respect to the first frame, and both the frames are inertial, in that frame also you will find that the time period is 2.0 seconds. Same experiment, same results. If you have a convex lens and you put some source of light here and you find an image, and then you see that okay, if this is 20 centimeters, that is 30 centimeters. If you repeat the same experiment in other frame which is moving with respect to the first frame with constant velocity, you get the same relation, 20 centimeter here, 30 centimeter there, laws of reflection, laws of refraction, all those things are identical. So, that is the meaning of this particular thing. If I look at the mechanics experiments, most of those mechanics experiments are governed by Newton's laws of motion. You can write F is equal to mass times acceleration, F equal to ma. For example, this pendulum experiment, there also is the same thing. You have tension, you have mg, then you have some resultant force, and that causes an acceleration. So, most of these mechanics experiments are essentially governed by this equation. What this postulate says that if you are in some frame F equal to ma, you go to some other frame, and in that frame you see what is the force, what is the acceleration, you still have the same relation there also. Now, I can connect the acceleration in one frame to the acceleration in other frame. I can connect force in one frame to the force in the other frame, mass, and we can verify. We can verify when you connect the velocity, position, acceleration of a particle or an object in one frame to position, velocity, acceleration of that same particle in other frame. So, those connecting equations are called transformation equations. So, let us take examples. Suppose I have a frame. What is frame? X, y, z axis. I know how to measure length, I know how to measure time, so that velocities and accelerations can be calculated, defined. So, I call a frame S frame. So, I have x axis, I have y axis, I have z axis, and this is x axis, this is S frame. And then if I take some other frame, the other frame may have orientation different, x, y, z orientations different, of course perpendicular to each other, and it can be moving in some direction with velocity v, which is constant in time, because we are only talking of inertial frame of reference. So, this is inertial frame. If resultant force on a particle is 0, there will not be any acceleration of the particle as measured from this frame. So, this is inertial. Same story here, if the resultant force on a particle is 0, no acceleration of that particle. So, this is also inertial frame, and this velocity is constant. So, if I have a particle and then I ask what is the position of this particle, from S frame you will have some x, y, z. So, you have the axis and you will draw perpendicular, etc., etc., and position will be defined like this in S frame. But if you are in S prime frame and then you ask what is the position, then with respect to these axes you have to find what are the coordinates, and those coordinates will be x prime, y prime, z prime. And then time. If this particle is here at this particular time, so what is that time? That is measured from this frame, that is measured from this frame, and that also should be connected to each other. What our general feeling or general observation or the kind of experience that we get from our daily life is the following. If you take a simpler picture, let us take a simpler picture where you have two frames x, y and z. I am not drawing z axis, it will be perpendicular to the board, and then you take yet another frame, S prime frame. So, x prime here, y prime here, and this is S and this is S prime. And to make things simpler, mathematically simpler, we will take up this simpler case where the axis of S prime are parallel to the corresponding axis of S. So, x axis and x prime axis, they are parallel, y and y prime are parallel, z and z prime are parallel. We will go further, x and x prime axis are coincident, same, on the same line. So, this is on the same line, x axis and x prime axis are coincident, one on top of the other. So, this is one. Then second is regarding the time measurements. So, if this origin is O prime, this origin is O, then at the crossing of O prime and O, since this S prime is moving with respect to this S in positive x direction, that also I will write. At certain instant this O prime must have been on top of this O. So, O and O prime are crossing each other that particular instant. So, at this crossing the time measured in this frame of that crossing is 0 and time measured in this S prime frame is also 0. Okay. So, you have clocks here in this frame, you have clocks in this frame, you have clocks. Using these clocks you can ask what is the time when O prime is crossing O. So, that time we will call it 0, t equal to 0, and similarly from these clocks you can ask what is the time when O prime is crossing O. So, we will say that okay, according to these clocks this time is t prime equal to 0. So, 1, 2, 3 and 4. S prime moves in positive x direction with a velocity v. These are the general symbols. These are the general symbols. We will use these conventions or these simplifications when we will talk about S and S prime. Whenever I say S and S prime, this will be the relation. These will be the relations. Axes of S prime are parallel to the corresponding axis of S, and x and x prime axes are coincident. When the origins cross, that time will be called t equal to 0 in S frame, that time will be called t prime equal to 0 in S prime frame, and S prime moves in the positive x direction with velocity v. So, this just to make mathematics simple, otherwise not very difficult. If there is an orientation, if the axes are oriented at some other angle, we know how to transform, right. We know how to transform this. We can do some trigonometry, not very difficult. We can do some trigonometry and get what will be this x prime in terms of x y z, y prime in terms of x y z, z prime in terms of x y z, and so on. We can do all that trigonometry and we can write the transformation equations, but to learn relativity, that is more important than getting into this complex algebra. So, we will be using these things. Now, suppose I have a particle. Now, suppose I have a particle out here, and this particle is here. This is called an event. Let me call this word also. I will be using this word many times, event. Event, something has occurred, something has happened, that is called an event. So, a particle is here at this position, this is an event, and for an event you have to answer two questions. One is where did the event occur, and the other is when did the event occur. So, it occurred at this position at this time. When you say this position and this time, you are talking of an event. So, a particle is here, this is an event, and for this event what is the position? If I ask this question to S frame, they will say that okay, it occurred at x y z, and if I ask the question when did this event occur, when the particle was here, they will say some t. But if I ask the same question to S prime frame, particle P is here, what is the coordinates, where is it? So, the answer will be x prime, y prime, z prime, and if the question is when was the particle here, when did the event occur, the answer will be some t prime. So, what we want is we want to connect this and this under these definitions or these conventions. So, that is the task, and this will be called transformation equation. So, let me make some space. So, from our own experiences, what we know is, rightly or wrongly, that t and t prime are same, first thing. If the clocks were reading t equal to 0, t prime is equal to 0 for one particular event, that means the clocks are compatible with each other, consistent with each other, and the time elapsed will be measured between this origin crossing, one event, and then this P is here another event. So, between these two events how much time has elapsed, that is this t, because t equal to 0 is that origin crossing, and that is t prime. Origin crossing is t.0, t prime equal to 0, and particle is here, that event is at time t prime. So, our experience, from our experience what we write is that t prime is same as t, that is 1. And then x, y, z. So, if I have to know this x, what I will do? I will drop a perpendicular on this x axis. Let me assume that it is all in xy plane, right, no loss of generality. So, I drop a perpendicular here, and what is x then? This is x. X is the x coordinate of this particle here, this point here. So, I drop a perpendicular on x axis, and this is x, and in this diagram what is this distance? What is this distance? When the particle is here, this origin is here, and t time has elapsed since the origins crossed. So, this distance is v into t. And what is x prime? To get x prime, once again you will drop a perpendicular on x prime axis, which will be the same, and then from the origin you will find what is the distance, that is x prime. So, this is x prime, from here to here this is x prime. And what you see is that this x is equal to this v t and plus this x prime, or x prime is equal to this x and minus this v t. So, you write x prime is equal to x minus v t. Okay. This is x, you drop a perpendicular, see the distance from the origin, that is the x coordinate by definition, and by the same definition this is x prime and this is v t. So, you have this relation. And y, what is y? This is y. For S frame, what is y? This is y. For S prime frame, what is y? This is y. So, y prime is equal to y. And if this particle is not in this xy plane, it is out of the plane, you will also have z, but then the same relation will hold good, z prime is equal to z. So, these are the equations which connect the primed quantities to unprimed quantity. If I know x, y, z, t, I can write x prime, y prime, z prime, t prime. These are called transformation equations, and this particular set is called Galilean transformation equation. These are called Galilean transformation equations, and this is the kind of geometry that we learn from our daily life events. Now, let us look at Newton's laws and acceleration in particular. So, how are the accelerations related? This is relation between the positions. Then how are the velocities related? What is Vx? Vx is dx dt. Velocity of a particle, let me call it u, ux, particle velocity. V we will reserve for the frame velocity. So, this particle at time t may have some velocity, and that velocity I am trying to write the components in S frame and S prime frame. So, in S frame the x component is ux, which will be dx dt, and y component will be uy will be dy dt and uz will be dz dt. Same definitions in S prime system, S prime frame, the x component of the velocity will be dx prime dt prime, y component of the velocity will be dy prime dt prime, and z component of the velocity will be dz prime and dt prime. And now use this, x prime is x minus v t. So, what is this dx prime dt prime? Ux prime is equal to dx prime dt prime, that is d of x minus v t divided by dt. T and t prime are same, therefore, dt prime and dt are same. So, you can write this, and this is dx dt and minus v. This t dt dt is 1. So, this is ux minus v. So, this was for position, and now I am getting transformation equations for velocities, and that is ux prime is equal to ux and minus v. First, similarly uy prime. So, uy prime is dy prime by dt prime, but then y prime is same as y. So, this is dy, dt prime is same as dt. So, this is dt. So, this is uy. So, uy prime is equal to uy, and similarly uz prime is equal to uz. So, these are velocity transformation equations, Galilean transform equations for position and for velocity here. And now come to acceleration. So, acceleration, you know what is acceleration? Once again, acceleration is dv dt or du dt. So, ax is equal to dux dt, ay is equal to duy dt, and az is equal to duz dt, and similarly for prime. Similarly for prime, ax prime is equal to dux prime dt prime, and ay prime is equal to duy prime dt prime, and then az prime is equal to duz prime dt prime, and then you can use these equations here. Ux prime is ux minus v. So, this ux prime is ux minus v. So, this you can write dt here, dt prime is same as dt, and this is ux minus v. V is constant, remember. So, dv dt is 0, v is the frame velocity. So, that is constant, and so it is dux dt, dux dt, and that is ax. That is ax, and therefore, ax prime is equal to ax. So, you write ax prime equal to ax. Y, similarly, what is ay prime? So, ay prime, if you are writing ay prime, this one you are writing, this is dvy prime. Now, uy prime is same as uy. Uy prime is same as uy. So, this is duy prime is duy, and dt prime is dt. So, it is ay. Ay prime is same as ay. So, ay prime is same as ay, and similarly az prime will be same as az. So, you have Galilean transformation equations for position, Galilean transformation equations for velocity, and Galilean transformation equations for acceleration. And accelerations are same, x component is same, y component is same, z component is same. So, if a particle has certain acceleration in S frame, it has the same acceleration in S prime frame. S prime frame has no acceleration with respect to S. So, it looks very natural, but keep fingers crossed, this natural thing may even become something else, but as of now accelerations are same. So, that is one. Velocities are different in x component, that frame velocity has to be subtracted going from S frame to S prime frame, and for coordinates these are the transformation equations. You can write reverse transformation equations. This I have written x prime, y prime, z prime in terms of x, y, z. If you want to write x, y, z in terms of x prime, y prime, z prime, t prime here, just reverse, v will become minus v and then primed and unprimed are changed. So, that gives you the reverse equations. That means, here it will be t is equal to t prime and this will become x prime will become x, x will become x prime, t will become t prime. So, primed and unprimed are interchanged and then v becomes minus v, because as seen from S prime, S is going in negative x direction. So, the same rules are applying, but v has become minus v. So, you will write x is equal to this, x is equal to this becomes x prime and then this v is minus v. So, it is plus v and then t prime. So, this is a general rule. I could have just said that see x is equal to x prime plus vt and t is same as t prime and therefore this, that is also perfect. But appreciate this, going from S to S prime, going S prime to S, what is the difference? The only difference is that S prime was moving in plus x direction, S is moving with respect to S prime in negative x direction with the same speed v. So, v becomes minus v and you have the equations, and of course, y is equal to y prime and z is equal to z prime. And similarly, you can write for these equations also and these equations also. So, we will stop today here, and my next task is to show that Newton's law F equal to ma, the form is same as you transform from S frame to S prime frame. So, if the form remains the same, F equal to ma here, F equal to ma there, then yes, the principle of relativity will be obeyed.